Welcome to the Staad Pro training course to learn how to generate seismic loads. Over the next series of videos, you will learn how to generate seismic loads in Staad Pro. This includes creating the seismic load definition and defining the seismic load items. In this video, we will be focusing on the seismic load definition. Staad Pro has the ability to generate loads to perform a seismic equivalent lateral force analysis according to a number of different codes and reference standards. In Staad Pro, load definitions are used to add supplemental information before the load can then be applied to the model. When it's applied to the model, it is actually applied in the form of load item and load cases, which we'll get to in the next video. The definition contains options to define code-specified parameters. For seismic, the load definition is created by selecting the appropriate code or reference standards. Then you would enter the parameters to define the seismic load, and finally you would then enter the loads that represent seismically active mass, or the mass that's assumed to be contributing to the base shear of the structure. To create our seismic load definition, we will open our Staad Pro model, click on the General tab, and then select the Load and Definition sub-tab. We will then expand the Definitions group, select the Seismic Definitions item, and then click Add. In the Add New Seismic Definitions dialog, we can then select which building code we would like to generate our equivalent lateral force procedure seismic loads according to, and we do include several American and international codes available. For this training course, we will select the IBC 2006-2009 code. Adjacent to the code selection, we will find our Include Accidental Load checkbox. The accidental load parameter prepares Staad Pro to calculate and apply torsional loads to account for code-specified accidental eccentricity. In Staad Pro, you can only include one seismic definition per model. So if any of your seismic load items wish to include accidental load eccentricities, you should select this checkbox. We will then complete the rest of our seismic parameters. In Staad Pro, we do have the ability to specify a zip code of your structure, which we can then use to populate automatically our latitude and longitude along with our SS and S1 parameters. For this model, we will use the zip code of 92887, and Staad Pro has automatically filled in these properties for us. We could also manually specify these if we wish. We will then enter our long period transition and enter that as 8 seconds. We can enter our importance factor, our response modification factors, and our site class. For this particular model, we will also enter our CT value, which will be 0.028 for this model, and our X of 0.8. After you've entered all of your appropriate seismic parameters, we will click Add, and we will see that our seismic definition has been added. Within the seismic load definition, you will also need to specify load items that will be considered to be part of the total that contributes to the seismic base shear of the structure. For each load item, the magnitude should be entered as a positive value to ensure that all loads will be additive. For this particular seismic definition, we will add the self-weight factor of 1.0. We will click Add, and we will also add some uniform member loads. So we'll select the member weights option, enter our loading type of UNI for a uniform load, and we can enter our weight of 0.05 kips per foot and then click Add. Once you've entered all of your information to be included in your seismic definitions, we can go ahead and click Close in this dialog. In the Load and Definition dialog, we're going to notice that our self-weight item has automatically been assigned to the model, but our member weights for our uniform load still need to be applied to the model. To do this, we will go ahead and select this load item, then we'll select the members to assign it to. For this model, we will go up to our Select menu bar item, select Beams Parallel to, and then we'll select our Global Z-axis. Once your members are selected, we will change our assignment method to Assign to Selected Beams, and then click Assign and confirm with Yes. Now these load items within our seismic definitions are just going to be used as part of the seismic base shear calculation. They're not actually loading the model as a dead load or a live load. Now with this seismic load definition, the design base shear will be calculated based on equation 12.8.1 of ASE 705 for IBC 2006. It will then be distributed to each floor, and a collection of nodes with the same y-coordinate value is considered to be a level for the purpose of determining the vertical distribution of seismic load in accordance with Section 12. Now for this particular model, our seismic definition is complete. We can actually only have one seismic definition per model, and now we can go ahead and, now that we've added our seismic definition, we can go ahead and incorporate it into some load cases as a form of a load item.